Now once you have all these different sentences converted into tokens, you think that you have completed your pre-processing, but that is not true, because after tokens what will happen is basically you will have to convert these tokens into numbers or vectors. So let us talk about this first. See, in the last class what we have done is basically we have gone and understood about different methods of tokenizations, and we talked about some libraries. So now we will talk about what happens once you have the tokens extracted, right? So now you have a sentence, you have the tokens. So the next thing you will have to do is basically convert those tokens into numbers or vectors. Okay, why is that necessary? See, if you talk about any model, any neural network model, right, all of them, their inputs are in the form of numbers. Think about or take any example. Okay, so any neural network, it always has numbers as inputs or vectors as inputs. So what you have to do is basically you have to convert your tokens into vectors, so that now these vectors can be fed into your neural networks, your model architecture or whatever, to give the results that you are required to have, right? So that is basically the whole task of this. So our first task has been completed. We have extracted tokens. The next task is basically, after you have extracted the tokens, is converting into numbers or vectors. Now there are a lot of ways in which you can convert this. So this vectorization thing, this process can be done in a lot of ways. Okay, today what we are going to do is we are going to talk about two things. We are going to talk about bag of words and the conversion, and then we are going to talk about TF-IDF conversion. Okay, so these two are one of the forms in which it can be converted. These two are also known as frequency methods to convert. Okay, so we'll be talking about frequency methods today. In the next class what we will do is we'll be talking about some other methods. Alright, so let us talk about this. Let us talk about what each of these represents and how we can convert. I am pretty sure you might have read about all of this when you were talking and studying and doing machine learning, but let us just go over and revise it one more time. Okay, so you have bag of words, in short BOW, right? So what this basically means is it creates a matrix. Okay, and this matrix basically, this contains the frequency of words in a document. Let us understand this in more details. Alright, so let us suppose you have D different documents for a corpus C. So for a corpus C you have D different documents, and each document has different number of words. So what we are going to do is, let's suppose we take n such different or unique words from this C corpus. Alright, so we have taken n different words or unique words from this C corpus. So what we are going to do is basically now we will be converting this based on the frequency of how they appear into a matrix. Let's say this matrix is M. Okay, so what will happen is basically, let's suppose this is your matrix. So here it will contain your terms. So term 1 or term 2, or let's say call this token 1, token 2, token 3. Okay, in that format, and you have document 1 here, document 2 here, document 3 here, and you have D such documents, right? So this is how it will go, and here it will contain the frequency of it. So I know this is not making a lot of sense right now, so let us just look into this with an example. Alright, so let's suppose we have 3 documents, and our documents are basically a cat sat, a cat in a hat, and a cat with a hat. Okay, so let's suppose these three are three different documents that we have, and what we are going to do is basically create a bag of words corresponding to this. Alright, so the first thing that we are going to do is find out the number of unique words. So you have a cat sat in with and hat. So that brings us to 6 unique words. Right, so this is our number of unique words. So what we are going to do is basically we are going to write a matrix in this format. So let us write all our unique words first. A cat sat in with hat, in with and hat. Alright, so this is one, and the other one here will be our document. So the first is a cat sat, a cat sat. Our second one is a cat in a hat, a cat in a hat. And the final one is a cat with a hat, a cat with a hat. Alright, so what we are going to do is basically we are going to create a matrix here. Okay, so let us see how this will be done. So this is our matrix. Let us look into this. So first we have a cat sat. So for this document, how many times do we have a? So we have only one. So here it will come to 1. How many times do we have cat for this document? We have 1 time. So it will come here 1. How many times do we have sat in this document? Only 1. So it will come down to 1. The rest will become 0 because we do not have the word in, with or hat inside this document, a cat sat. Alright. The next thing that we are going to do is go and do the same thing for our second document. So how many times do we have the letter a? So this is 2 times now. So this becomes 2 here. Then how many times do we have cat? Only 1 time. So this is 1 again. In, so there is no sat here. So this becomes 0. We have then in once. So here it becomes 1. A is already done, and then we have hat here. So this becomes 1. This comes to 0. The final one is basically a cat with a hat. So you have 1 here. Sorry, 2 A's. So this becomes 2. My bad. So cat becomes 1, sat is 0, in is 0, with is 1 and hat is 1. Okay, so this is basically the matrix that represents this. Okay, but you might think, you might be having a lot of questions. So let us respond to each of this, okay, one at a time. So the first thing is basically, see, this is going to be a sparse matrix. If you talk about this, this is going to be a sparse matrix. Sparse matrix is something where maximum of the words are 0. Okay, maximum of the values are 0. So this is a small matrix, hence you are not able to understand. But if you look here, see, this is 0. This whole thing here is 0. So if you increase the number of words, number of tokens, in that case most of those are going to come to 0. Alright, so this is going to be a sparse matrix. The next thing is basically, see, this example that I took, this example was a very small example, right? Small example as in the number of documents were small, the number of unique tokens were small, so everything was small here. So what we are going to do here for the next thing is, if suppose we have a very big data, okay, let's suppose we have, I don't know, 100,000 documents, and these documents, each document itself has like 10,000 words. So this becomes huge. If you think about the matrix will be 1000 cross 10,000. So this is a lot of work and everything. So what happens in this case is basically we do not take 10,000 unique words. Okay, in that case we reduce the number of unique words and we take the topmost unique words that are used. Okay, so we will not be taking 10,000 unique words, we'll reduce this to 100 unique words or something like that. Okay, so that is one of the things that can be done. So this was the whole thing about bag of words. Alright, I hope you understand. So the whole point of what happens here is basically you have documents, okay, and for each of the documents what you will do is you will extract n number of unique tokens. So once you have these tokens, or once you have these extracted words, the next thing that you are going to do is basically you're going to plot it out in a matrix format, and then you're going to write the number of frequencies. That is the frequency of the number of times this word has occurred. Once you have that, now this matrix is basically what can go into for training. So that means this here this sentence, a cat sat, has this as its, this is basically the vector of this sentence, a cat sat. So now I can represent a cat sat as 1 1 1 0 0 0. Okay, so this vector will now be used. Alright, so this is how we converted this whole sentence into a vector format. Alright, so this was the first thing. So now let us talk about the problems with bag of words. So one of the biggest problems is sparse matrix. Since you might not have most of the words in a sentence, right? So most of it is going to be 0 anyway. So in that case, what is going to happen is basically you're going to be left with a matrix where the number of values are very less and most of it is filled with zeros. Alright, so in that case what you can do is, so what will be the problem with this? So the other problem with of sparse matrices, see, high computation, since the matrix keep increasing. And the second thing will be, the other problem basically, this will be large storage space. So you will require a very large space to store the whole thing, right? Hence this can be a problem, this whole bag of words thing. Okay, so we come to the next problem. Okay, so our next thing that we will talk about is TF-IDF. So TF-IDF, as the name suggests, TF-IDF stands for term frequency and inverse document frequency. So this is what TF-IDF represents. Alright, so we are going to understand about term frequency and IDF, that is inverse document frequency. So here also what I am going to do is, see, it is always easier to understand it using a example. Alright, so here also what we are going to do is basically we are going to talk about and go through an example and then we'll see and understand the whole point of this. Okay, so let us suppose we have two documents, D1 and D2. Alright, so in the first document, let's say this is the number of words. So this is about Messi, and then here you have, this is about TF-IDF. Alright, so you have two documents in this manner. Okay, in this document, this is the count of words. So this is basically the count of words for D1 document and D2 document. So D1 document has, this is about Messi, these are the different tokens, and this is repeated once, is repeated once, about is repeated once, Messi has been repeated 4 times. In the same way, D2, you have, this is about TF-IDF, this is the other document. Here also this is repeated once, is repeated once, about is repeated twice, and TF-IDF is repeated 4 times. Alright, so what we are going to do is basically find out the term frequency first. Once we understand term frequency, we are going to find out the IDF value of this. Okay, so let us start with term frequency. So term frequency is basically the frequency of the term in the document. So let us say, so let me just write this again. Alright, so D1, this is about Messi. D2, this is about TF-IDF. So this is 1 1 1 4 and 1 1 2 4. Right, so this is basically our whole thing. So what we are going to do is we are going to find out first the term frequency. So the term frequency of, let's suppose, this word here. Okay, so term frequency is basically the number of times a term exists in a document. So this is basically the whole term frequency. Alright, so for term frequency, the whole formula is basically the number of times the term has appeared divided by the total number of terms. Okay, so that is what we are going to do. So we are going to find out the term frequency of this in D1. Okay, So the term frequency for this token in D1 is basically 1, because the number of times this has appeared is once, and the total number of words, so that is 4, 5, 6, 7. So 1 by 7, this is the term frequency of here, this. Okay, now in the same way you can find out the term frequency of this in D2. So term frequency of this in D2, this will be equal to, so the number of times this is there, so that is once, divided by the total number of times, the total number of tokens in this document, so that is 4, 5, 6, 7 and 8. So this comes down to 1 by 8. Okay, so that is one thing. So term frequency basically means the number of times a particular term has appeared. So let's say if we are talking about a particular, let's say we have an article which talks about Messi a lot. Okay, if it talks about Messi a lot, the number of times Messi is going to appear in the article, the name Messi is going to appear in this article is going to be a lot. Hence what will happen, if the number of times this Messi appears is a lot, the denominator will automatically increase and you will have an increase in the term frequency. See, since the document is about Messi, the word Messi is going to be there a lot. Okay, so if you are searching about Messi, the chances that this comes in above in your search list is very high, because you are talking about this, right? So that is why what we're going to do is basically understand this. So the term frequency, what it basically means is, if there is a word which is relevant, okay, so in that case what will happen, the word will appear many number of times, and if it appears many number of times, the chances that its term frequency is also increasing. All right, so that is what the whole thing is about. The next thing that we're going to talk about is IDF. So IDF is basically inverse document frequency. So let us talk about how this works. All right, so IDF is basically log of capital N by small n. So let us talk about this. So capital N basically means total number of documents, and small n means number of documents where a particular word appears. So let's say we are talking about IDF of this word in D1. Okay, so we're going to talk about IDF, or finding the IDF of this keyword in document D1. All right, so this will be basically equal to log of capital N. Capital N means total number of documents. So we are talking about 2 documents here, so capital N turns out to be 2. Now the number of documents, in the number of documents this word appears. So this appears in document 1 as well as it appears in document 2. So hence the number of times this appears is 2, or the number of times this is there in a particular document is 2. So in that case what this comes out to be, this comes out to be log 1, which is equal to 0. So what IDF does is basically IDF values, it values the number of times a particular thing appears. So there can be a lot of words. All right, so there can be there can be this, there can be so many different types of words. All right, and these words are going to be appearing from each and every document. So it is going to appear each and every document regardless of the document, right? So that is why what happens is, if you do the IDF, all these words that are very common that appear in every document gets removed and the IDF value comes to 0. Now what we're going to do is basically we're going to find out TF IDF of, let's say, the word Messi in document 1. So first let us talk about the word frequency. So the number of time Messi appears. So Messi appears 4 times. So this comes down to 4. And this will be divided by the number of tokens in D1. So D1 number of tokens are 4, 5, 6, 7. So you have 4 by 7, alright, and this will be multiplied with IDF. So IDF is basically log of capital N, that is the number of documents. Since we are using 2 documents, so our number of documents becomes 2, divided by the number of documents in which Messi appears. So Messi appears in only one of those documents out of these 2. So this becomes 1. So this comes down to 4 by 7 log 2. Now here is the thing, if you talk about TF IDF, so this is TF IDF for Messi. If in the same way you talk about TF IDF of, let's say, this word about, okay, So if you talk about this about in, let's say, D1, so in that case what will happen? The term frequency is going to be high. So the term frequency of D1 here is 1, is 1, and that is divided by the total number of words. So that is 4, 5, 6 and 7. So this is 1 by 7, the term frequency. What is the IDF here? So the IDF will basically be the number of documents, that is 2, divided by the number of times is appears in the number of documents. So that is again 2. So this will be log of 2 by 2, and this will come down to 0. So here you can see what this does is basically it gives a higher priority to what? It gives a higher priority to words that are more relevant, because here you see this is not 0, this is 4 by 7 log 2, but here this comes to 0, because we all know, if you think about it intuitively, about word is way smaller or way less significant or way less relevant compared to the word messy, right? So that is why this is used a lot, TF-IDF. TF-IDF is also one of the things that was used, that is still used, I suppose, in Google search engines. Okay, so this is basically used to find out or to value or give more higher ranking to some websites depending upon what words they have used. Alright, so this is it. And one other thing is, first let's go back one more time. Okay, so bag of words was basically, if you think about it, this was basically a kind of matrix in which each square or each box represented a number of times a term appears in a particular document. All right, so that was the whole thing about this bag of words. Then we talked about TF-IDF. TF-IDF, what it did was find out the term frequency of a particular word, and then that was divided by the number of times, the number of words in that document, and then again it was multiplied with IDF. What was IDF? IDF was log of number of documents divided by the number of documents in that where this particular term appears. All right, so that happened, and then you were getting all these values. So in short, TF-IDF gives a higher score or a higher rating to sentences or to areas that are more relevant to what you were searching for. All right, so that is one thing. So now if you can think about it, what happened is basically you can find this TF-IDF for each word. So you can find TF-IDF for each word. Once you have this, you have basically a vector where each word is represented by a particular number, and then hence the whole sentence is represented by what? So it is represented by a particular vector. So that was the whole thing about TF-IDF. I hope you understand the video. If not, take some time, go back, revise and understand everything that is happening. In the next class, what we will be doing is we will be talking about predictive tokenization or predictive embedding. So in this, what happens is not tokenization, embedding is a better word. So in this, what will happen is basically we will be using something known as autoencoders. We'll be understanding about this. This is also kind of a neural network. So we'll be talking about autoencoders, and then we'll see how autoencoders can be used by us so that we can convert D dimensions into smaller ones. So we'll talk about this, we'll talk what this means and how this happens, but the whole point of this is, see, as these are old techniques, okay, these were used earlier, now they are not used, does not mean that you do not have to learn about this. There are chances, TF-IDF is one of the very most common topics, so there are chances that you might actually come across this. Okay, so I hope you enjoyed the video and keep learning.